Good day, everyone. This is OA Ario. I'm your course facilitator and tutor for this course MTH 102 Elementary Calculus. In this course, you will be learning a lot of calculus concepts, starting from the function to limit to the idea of differentiation and then the integration. On the LMS page, we have updated several things for you to familiarize yourself with the university and then to welcome you to campus. In the last week, we were able to address some of our students that are offering this course MTH 102, and we expect that you will excel in this course. Today, we are looking at function, and then we'll be checking concepts, notation, and classification of functions. Normally, you should be able to define what a function is or what a mapping is, okay? Then you should be able to differentiate between a function and mapping, because usually we have that every function is a mapping, but a mapping may not be a function. A mapping or a function is any mathematical rule that assigns to each member of the domain a member of the codomain or range. What this means is that a mapping or a function shows relationship between two sets. One of the set is called the domain and the other one is called the codomain. I can denote a set as this. Let me call this set a set X, which contains some member which I can say maybe A, B, C, D. Okay. And if I have another set, say set Y, and say we have the members of this set to be U, V, say X, W, and Z, okay? So any mathematical rule that relates this set X to this set Y is said to be a mapping or a function. And such a mapping does this, okay? I call it F. What this function does is that it maps A in the set X to U in set Y. It may take member D in X to V in Y depending on the rule of F that governs this mapping. C may be taken to say W, okay, depending on how the function is being defined, okay. But what we have done here is F is obviously a mapping, okay, but F becomes a function when the member of Y are set of numbers. Then we say we have a function, okay, where we are taking our members from, which is X. This set is then called the domain of the function, and when we put each of the members of this X of the domain into F, we get a result, and the set of result is where we have our Y. So in this Y, this set becomes the codomain, okay. We say set Y is the codomain, or sometimes we say it is the range. The difference between codomain or range, or when do we say Y is codomain or Y is a range? Now just observe, you see that as we map this function, it is not all members of Y that are mapped. U is mapped, V is mapped, W is mapped, X is not mapped, Y Z is also not mapped. So when not all the members of this set Y is mapped just as it is, then every one of the member of Y here is called an image of the members of the domain, okay. And here we have the codomain because not all of them are mapped. But in the case where all of them are mapped, let's say we have B mapped to X, and maybe all of them are mapped, we still map A to Z because it is possible that single element like A can be mapped to two different members of Y. So in this case now you see that all members of Y are mapped, then Y becomes the range of this domain. Okay, suppose that we still have that Z is not mapped, okay, then the codomain is the whole set of members of Y, which is U, V, X, W, and Z, okay, but the range in this case will just be U, V, X, and W. So the range is a set of numbers or members of Y that have pre-image. Okay, um, each member of the domain is called a preimage, and each member of Y is called a image. Okay, we are trying to do the notation now that a function can be written as f, which takes say x. This means such that x is taken to y, set x is taken to set y. So that is, it takes every member of x. Okay, I use small x for that. It takes every member of x, it maps to each member of y, okay, such that we have that function of x is going to be equal to y. We have that value of y is dependent on the values of x, because before you can have a result, before you can have any member of y being generated, this member depend on whatever you put into the function f. Okay, so these are some of the notations that we have. A brief understanding and knowledge of functions, its concept, notation, and we'll soon look at the classification. But before we look at the classification, let me give us an example of function. For example, we can have a function that is defined such that x is taken to x squared. Okay, this is a function that is, I can write some members of this set is taken to some members of this sets. So the function is defined to be, say, x squared, which takes every member of x here to some members of y here. So let's say we have some members here. Say we have minus 1, 0, 1, okay, 2. Let me also add minus 2. For each x here, if I put minus 2 into this function, what do we have? So that is minus 2. When x is minus 2, so that is minus 2 squared. We're going to get 4, isn't it? 4. Then if you put minus 1 squared here, you get 1, right? If you put 0, 0 squared is 0. And if you put 1, you get 1. Okay, so 1 is already there. I don't need to repeat it. You know, normally there's no need for repetition in a set. Then 2 squared is also 4. You see that? So what this mapping has done, what this f has done, is that it takes minus 2 to 4, it takes minus 1 to 1, it takes 0 to 0, okay, and it takes 1, okay, to 1 again, and then it takes 2 to 4. All right, so normally this is a kind of in the classification, this is a many to one function because it takes more than one members of the domain to a single member of the codomain in this place, or of the range in this case. Okay, like for example now minus 2 and 2 are taken to 4, so this is many to one kind of function. Okay, so this is a very clear understanding of what function does, and then we can write that f of x equal to x squared. That is a function. Let me give us an example of a function. Let's say we have this function f of x, which is equal to 2x plus 5. So when we take f of 2, that is when x equal to 2, so that is just a substitution. So when x is 2, what do we obtain? You see that we obtain 4 plus 5, and this gives us 9. So it means that in the domain here, when we have 2 here, the map does this. It takes 2 to this member, 9 here, and the function is 2x plus 5. Okay, so you have seen this before. Normally we can write y equal to, okay, so you have seen this before, that y equal to 2x plus 5. So and this is the, say, the range in this case. Okay, this is what a function does. On the classification of function, I will give a few in this video, then I'll complete this in the next video. I've talked about the many to one function, in which case you have more than one member of the domain, okay, mapped to non-unique member of y. Say we have some members a, b, and c in this case. So if we have x takes to a, say we have y takes to b, and then we have z takes to c. If we have, let's say, y is taken to c, for example, you can say that y and z are mapped to c. So that is many to one function. If at least we have such a case, then we say that this kind of function is a many to one function. Then we can also have what we call the one-to-one function. So just like the name implies, one-to-one function. This function is also called an injective function, in which case we have, let's say we have x, y, z, and then we have the range here, say a, b, c, and if each member of the domain is mapped to one and only one member of the range, then we say we have a one-to-one function. Look at this function. X takes to c, y takes to a, and then z takes to b. So each member or unique member of the domain is taken to unique member of R. So there's no two members that is taken to one member here, or there is no single member that is taken to two members in the ring. So this is one-to-one function. It can be written as one-to-one. This way is called the injective function. So we say a function is injective if given that f of x equal to f of y, then it could only mean that x is equal to y. Okay, or if f of x is not equal to f of y, it only means that x is also not equal to y. So these are the definitions of one-to-one function, and the function that is defined this way, y equal to 2x plus 5, is a one-to-one function, because for every member of x that you put for this kind of function, you will get a unique member of y. Another example of such one-to-one function is y, or f of x, which is equal to, say, x raised to power 3. It's a one-to-one function. Onto function. An onto function is also called a surjective function. For a surjective function, we have such that every member of the codomain or the range has a preimage in the domain. So suppose that we have a, b, c, and d here, and then let's say we have maybe x, y, and z. Okay, so every member of R has a preimage. I told that a preimage is a member of the domain here. So if every member of our R has a preimage here, then we say that such a function is surjective. That is, every member here has a unique member mapped here. So there's no one of them that is left behind. So say we have this y to x, c. So all of them are mapped. So this is a kind of surjective mapping. It's also called an onto mapping. So any function that is injective, that is one-to-one, and is also onto, that is surjective, we say such a function is a bijective function. So a bijective function is a function that is both one-to-one and also onto. So we continue this discussion in the next video. Thank you for staying still. I remain your tutor, Olubukola Amos Ario. Thank you.